Hello and welcome to this tutorial about how to create a runtime. What we are seeing here is a blue pill that has a blinking LED and it's executing this model we see here, and it's using the embed runtime here. The configuration, the model we are executing is blinky, and we are in the blinky configuration of the project embed nodes. You can both download these projects from GitHub and add this to your workspace. But what we are doing now is we are not going to talk about this embed runtime, but we're going to talk a bit more general about runtimes and how you create your own. So here we are at the documentation, and here's runtime. So first we need to clarify what a runtime is. You may know it from other videos where I have talked about the simulation runtime, and most of the time we are executing the live runtime. In the normal setup, this embed runtime isn't even there. So, what have I done? Let's go back here. So, what is a runtime? The runtime is basically the layer between the operating system and the model, and it does the communication, so the data exchange between ABMT. And it's also a template for the build environment. So when you click the play button, it creates a build directory, or ABMT creates a build directory. It adds the model, it adds the workspace, it adds a configuration JSON, and a lot of other files that are even mentioned here. And there's also runtime files that execute this model. And that's basically what a runtime is from a directory view. So the runtime provides the execution environment and the build environment, and ABMT provides the model. So that's a bit confusing, but let's start right away, and it will be very easy, as you see. So here is something, so ABMT provides a model in the workspace, and the runtime provides a build script, a start script, maybe a config definition, and many other files, and build files, object files, and so on. So yeah, basically just start. You will see. I see you have many open questions, but it's easier than you think. So let's go to our example workspace and create a directory with the RT prefix. So mkdir rt x, for example. Let's restart ABMT. And now we already see that we have a new runtime here. When we click play, it says that it hasn't a build script. So let's go back to runtime. RT example, and let's add a build script. So you can also use Python if you want. We just so that's it. As I mentioned already, we also need a start script. So we do this at the same time. Bin bash echo. So now let's restart ABMT. Here we go. And click play. Oh no. No. I forgot to make these executable. It's good that I forgot it. Now you know. Mod x. This is no plus x. I'm a bit confused today. Sorry for that. So there they are. And now it will not work. Now that's something I don't like, but it's like that because the synchronization between the build directory and the runtime directory is only in one direction. So every file that's in the build directory also is copied to the every file that's in the runtime directory is also copied to the build directory. Every file that exists in the build directory is left like that. ABMT checks which file is new and then updates it, but in this case it did not recognize a file change because we changed the attribute and not the file. So that's a bit buggy, but yeah, you will not be confronted by that very often. But you will be confronted by a messed up build directory if you make changes to your runtime. So when you develop a runtime, make sure that you often clean up your build directory. So now everything should work. And it does. Here we have hello runtime, here we have start ... So that's basically how to create a runtime. Put your build instruction into the build script and put your startup instructions into the start script. What we do now is we look into the generated build directory that you see that once again. So example workspace, we are in the embed nodes directory and have the, here you see a runtime from an old videotape. We are here in the X. So here we see a lot of files that ABMT creates. Here's the model CPP, so you have to compile this with your build script. Here are some examples, you may not need them. Here is the shared library from ABMT for image processing, and also here, for example, for the model adapter for the communication. And here are the nodes. And from every node you use or every project you use, every header file is copied, but only the CPP files that are needed. So you have access to all the header files, because it's very often that you include another header file from the same directory in your CPP file, and that's why all headers are copied. ABMT also updates these directories and removes object files that are not needed anymore, but only in the workspace directory. So embed ABMT manage the workspace directory, the rest is left for the runtime. So that's basically how a runtime works. And for the second part of this video, we look a bit into the embed runtime, because it's a bit special and it uses some tweaks to get the communication done and get everything to work on a microcontroller. So we do this by inspecting our code, and we start with the startup and UR2 ABMT. So the build script basically flashes the controller, and the startup script starts a command named UR2 ABMT, and it's basically piping all the data that comes from the UART port to ABMT, because ABMT only listens to the model port at localhost, and we need to get the data from the microcontroller to ABMT, and this is done via this executable that's compiled and executed in the start script. And this basically waits for the USB port to appear. Then it opens the USB port with the port and the baud rate. Then it opens the TCP connection to localhost with the ports. And basically every time when the TCP connection receives new data, it sends it to UART. And every time when the UART receives something, it sends it to the TCP connection. Here's the endless event loop, and that's basically how to transfer data from UART to ABMT. So now let's go to the more funny part. This is also not needed anymore. Let's look into our main CPP file. So this main file basically executes every raster and it sends the data out to UART. So the communication is done via this adapter, and the adapter puts its data, where we are, into these buffers, and here in the main loop these buffers are filled and sent out. So when we have data to send, we send it via our communication device, and when our communication device receives something, we send this into the in buffer, and the in buffer is linked with the adapter. So this is how the adapter receives its data. It's basically the same adapter as for the live and the simulation runtime. You can look into this yourself. So this is how the data is done, and there are other things done here we go through. So basically the OS implementation here is done in the main file, so you can have your logging functions and your die if function here. They're implemented here. Basically it sends all the log data via the adapter to ABMT, so you have it in your GUI. And this die if, very simple. This one we skip. So the embed nodes have in their interrupt service routines call this function, and here you can add code to wake up ABMT if you have a bare metal profile or a single threaded event loop calling all the rasters. Here the embed runtime uses threads to manage the rasters, so we don't need to trigger our event loop. So what's next? The time implementation. So these OS function and the time implementations are the only things you have to implement for the library, for the shared files. Yeah. And here we are with our thread. So then this is a class that implements a raster or executes a raster. It takes the raster here, creates a thread, goes into this run function, and then here in endless loops it triggers the raster it received. So yeah, it's basically the same as in the live runtime. Yeah. The simulation runtime has its own time implementation and of course its own trigger class. So basically we create an instance of this embed raster class for every thread. We do this here. So yeah, we start every raster in this loop, then set up the adapter, and then send every data out to the adapter, from the adapter to ABMT, and the other way around. So yeah, this is basically it. If you want to look into the communication stuff and so on, just download it and look a bit deeper into that. If you have questions, just write a comment, then you help others that have the same question. So thank you very much and see you next time. Bye bye.